All right, what's going on, y'all? We are going to do some exponential transformations. So without further ado, let's get to it. I'm really sound like a YouTuber right now. It's pretty cringy. I don't know. I think it's funny. Let's keep going on with the meme. Anyways, we got a function here. F of x is equal to 3 to the x minus 2 plus 1. So we got Harry Styles rocks V-necks. Y'all should know this by now. So first, do we have any horizontal shifts? Well, if you take a look, we got x minus 2 up here. So this minus 2 is our h value. So we are going right 2. All right. Do we have any stretches or compressions? All right. So I know that this is going to trip y'all up some. So I'm just going to address this right now. Don't mistake the base for a stretch or compression. So let's say you have, 2 to the x. This is not a vertical stretch of 2. This is not a vertical stretch of 2. This means base is equal to 2. All right. I'm just going to make that clear right now. It's not a vertical stretch of 2. The base is equal to 2. So in this case, we have no stretches or compressions. All right. Do we have any reflections? We don't have any negative x or a negative on the outside, so we have no reflections. And we have a vertical shift up 1 because we got plus 1 on the outside. All right. So let's take a look at what this is going to look like on the graph. Let's take our table. We got 0, 1, and 1 comma b. Well, b is 3. So we're going to have 0, 1, and 1 comma 3. And first we're going to move everything right 2. So right means, you're going to shift your x's. It's horizontal. And since we're shifting them, we're going to add. So we have 0 becomes 2. And then 1 plus 2 is equal to 3. And our y's values stay the same. All right. And then we have up 1. So we got x and y. And we got 2 comma 2 because we're adding 1 to the y's. And then 3 comma 4. So let's go ahead and plot this. We got 2 comma 2. And then 3 comma 4. All right. So a good thing to take into account is what the horizontal asymptote will be. So remember, originally the horizontal asymptote is y equals 0. Now, if we shift it up 1, the horizontal asymptote is going to go to y equals 1. So let's go ahead and plot that. Here's our horizontal asymptote. And then we can graph our function. We got something like this, an exponential growth function. The domain is going to be x is an element of the real numbers, and the range is going to be everything from 1 to infinity. So this is a good example of a exponential growth function. So let's go ahead and look at an exponential decay function. So we're going to graph and analyze this function. F of x is equal to negative 2 times 1/2 to the x power. Let's go ahead and list our transformations. So we got Harry Styles rocks V-necks. All right. So H, do we have any horizontal shifts? No. What about a stretches or compressions? We do this time. 2. This is a vertical stretch of 2 because we get multiplied by 2. Do we have any reflections? Sure do. We have a reflection over the x-axis because our negative is on the outside. Now, if we had a negative x up here, That would be a reflection over the y-axis. Do we have any vertical shifts? No. So let's go ahead and write our parent function for this. We have 0, 1, and then 1, b. So b in this case is equal to 1/2. So let's go ahead and do these transformations. We got x and y. Let's see, we have a vertical stretch of 2. So since it's vertical, it's going to affect the y coordinates. So here are x coordinates. Since we're stretching by 2, we're going to multiply by 2. So 1 times 2 is 2. 1/2 times 2 is 1. All right, so now we have to do a reflection over the x-axis. So if we're reflecting over the x-axis, it's going to affect the y values, and we're going to multiply them by -1. So 2 is going to become -2. 1 is going to become -1. Now let's go ahead and plot these points. So we have 0, -2, and then 1, -1. So we should have something quite interesting. So let's go ahead and draw this. And bam. It's a reflected exponential decay function. So our domain in this case is going to be x is an element of the reals. And our range is going to be everywhere from -infinity to 0, because our horizontal asymptote is y equals 0. So that's it for exponential transformations.